Alright, this is the summer school study guide final for the final. And so you should have your study guides. I'll start with number 1, and I'm just going to go through this kind of quickly. So feel free to pause as we get to them and try them yourself, and then you can use my work to check. Alright, so number 1 says to simplify the following. Alright, so essentially with these, what we want to do is eliminate any exponents we can, and we also don't want to have any negative exponents. So the first thing I notice is that this, specifically x to the 0 is the same as 1, so we can rewrite this as 9 times x to the 0, which is just 1, times y to the negative 8, all over z to the negative 8. So we can take that one step further. 9 times 1 is just 9, so we end up with 9y to the negative 8 all over z to the negative 8. Now if you recall from one of our first days in summer school, anytime you have a negative exponent, you can take it and put it on the opposite side of the fraction. So notice that both y and z have a negative exponent. So we're going to take the y and flip it to the denominator to make it a positive exponent. And we'll take the z and flip it to the numerator to make it a positive exponent. So what we'll end up with is 9z, and it used to be negative 8, now that we moved it, it'll be positive 8, over y, and again it used to be negative 8, but we moved it, so now it's positive 8. This is your final answer. Alright, number 2. Number 2 is the same kind of problem. It says to simplify the following. We have 8w to the 0 power, r to the negative 7th, all over 2 to the negative 8. So again, first things first, I'm going to start with this w to the 0 power. So that's going to become 8 times 1 instead of 8 times w to the 0 power. Eight times 1 is just 8. Now once again, because this is a negative exponent, we can throw it down on the bottom to turn it into a positive exponent. As well as we can take this, because it's a negative exponent, throw it up to the top to make it positive. So what we'll end up with is 8t to the 8th power divided by r to the 7th power. And that's it. Alright, number 3 is the same kind of question, so I'm going to run through it real quickly with less explanation. Alright, and that's number 3. Now, let me go back and erase some of this. Well, I'll scroll up here. Number 4 asks you to complete the table. You should have an almost identical table to this in your notes, so I'm not going to go over this one. If you have questions about this one, you can come talk to me. Number 5. Number 5 says to multiply. We have n minus 5 times n minus 1. And if you'll recall FOIL, we do n times n, which is n squared. And then we're going to take n times negative 1, which is negative 1n. Negative 5 times n, which is negative 5n. And negative 5 times negative 1, which is positive 5. Now we're not quite done. We can still combine like terms. They're both in n's. So we'll end up bringing this down. Negative 1n minus 5n is negative 6n. And that is that. Alright. Number 6. Number 6 is the same kind of problem. It says we're multiplying r plus 7 times r minus 7. And again, we're going to start with FOIL. R times r is r squared. R times negative 7 is negative 7r. 7 times r is positive 7r. And 7 times negative 7 is negative 49. Now, notice that negative 7r plus 7r becomes 0r, so those will just cancel out. I'm left with r squared minus 49. Number 7 says to write the polynomial in standard form, so I'll write it as it is now. So in order to organize this in standard form, I have to go through and arrange it by its exponent. So you'll notice negative 12x to the 5th has the highest exponent, so that's where I will start. Next up is 2x to the 4th. After that, we've got negative 5x cubed. Then we've got 3x squared, negative 8x, and last but not least, negative 6. The second question is to give the leading coefficient. Well, the leading coefficient is a number attached to x. So the leading coefficient is right here in negative 12. Number 8 says to find the prime factorization of 70. So when we did this, we just broke this down. This becomes 7 times 10. And 7 is prime, so I can go ahead and circle that one. But 10 can be broken into 5 times 2. And both 5 and 2 are prime. So my prime factorization is 7 times 5 times 2. Now, number 9 is the exact same question, so I'm not going to go over that one. And we'll just move on to number 10. 10 says to find the GCF of 2m to the 5th, and 32m to the 4th. So remember, this is where we broke these down. The 2m to the 5th is 2 times m times m times m times m times m. And 32 to m to the 4th, well, that's going to be, let's see, 32 breaks into 16 and 2, which breaks into 8 and 2, which breaks into 4 and 2, which breaks into 2 and 2. So we've got 1, 2, 3, 4, 5 2's, so 2 times 2 times 2 times 2 times 2. And then we've got m to the 4th, so times m times m times m times m. And now we can look for our pairs. We've got a pair of 2's here, so we can bring those down. And we've got no other 2's in the top part, so I can't there. But I've got a pair of m's here, so I can bring that down. And I've got a pair of m's here, so I can bring that down. A pair of m's here, so I can bring that down. And a pair of m's here, so I can bring that down. I multiply them together. 2 times m times m times m times m, well, that's just m to the 4th. And that is my GCF. Number 11 asks you to find the GCF of 4y to the 5th and 2y to the 2nd. So again, we'll just break these down. This becomes 2 times 2 times y times y times y times y times y. And 2y squared becomes 2 times y times y. Again, we're just looking to find things we have in common. We've got a couple of 2's here, so I can bring that down. I got a couple of y's here, and a couple of y's here, and that's all I have in common. And this becomes 2y squared. Alright, 12 is another GCF problem. So if you want to take a minute or skip ahead, I'm going to erase all this stuff. If you have any questions while you're doing the study guide, be sure to email me. I mean, if it's like midnight, I might not answer, but most of the time I'm pretty good about checking my email. Okay. Number 12. Again, it's a GCF problem, and it gives us 6a to the 4th and 20a cubed. So when we break this up, this becomes 2 times 3 times a times a times a times a. And if you're not ever sure what the number becomes, you can take it and you can do your prime factorization. So this becomes 10 times 2, and that becomes 5 times 2. So I know my prime factorization, all of these into pieces. So I've got 5 times 2 times 2 times a times a times a. So now I'm going to look for common things. I've got a 2 and a 2, so I can bring a 2 down. I've got an a and an a, so I can bring an a down, a and an a, bring another a down, a and an a, bring another a down, and that seems like that's it for common factors. So this multiplied out becomes 2a cubed. Okay. Number 13. Number 13 says to solve by factoring. So you can use the guess and check method or the box method. I'm going to show the box method, but if you use the guess and check method, that's okay. So our problem is x squared minus 2x minus 24 equals 0. In order to do the box, you need to know the AC value. In this case, it's negative 24 times 1, which equals negative 24. And so now when we make our box, we have, ooh, that wasn't good. We have x squared and negative 24 here. Now we're thinking of things that can multiply together to be negative 24 and add up to be negative 2. I believe that negative 6 and 4 will work. Yes, because negative 6 times 4 is negative 24, and negative 6 plus 4 is negative 2. It checks out. So now we factor out what we can. The largest thing I can pull out from this row is an x. Leaves me with an x here, and leaves me with a negative 6 here. Now, looking at the column, I pulled out an x at the bottom there and left with a 4. So my two factors are x plus 4 and x minus 6. And notice this just says to factor, or it says to solve by factoring, excuse me. So we do need to go and solve it. So this is equal to 0. So we'll set x plus 4 equal to 0. And over here we'll set x minus 6 equal to 0. I'll subtract 4 from both sides here, and we get x is equal to negative 4. I'll add 6 to both sides here, and we get x is equal to positive 6. And those are my two answers. Alright, number 14. Again, this is solved by factoring, and it gives us x squared. Do I have the right one open? One second, I think I have the wrong thing open. Oop, I never went back and changed those. So, because I'm already making this video, I'm not going to worry about that. I will change them for your study guide, but if you have questions on those, please email me. Alright, so we're going to jump to 16. Go ahead and erase, go ahead and erase all of this. Okay, 16. 16 says to solve using square roots. A lot of people made pretty easy mistakes here, I think. So to undo this using square roots, you just literally use square roots. Here I'm left with x, and here I have plus or minus 11. Please remember the plus or minus. So many students forgot that. Alright, 17 says 2x squared plus 128 equals 0. Oops. So first, we'll subtract 128 from both sides. So you should get 2x squared is equal to negative 128. Then we divide by 2. Many people took the square root at this point, but you can't do that yet. Remember, if we're digging out that x, we have to go reverse PEMDAS. Let's see, 128 and a half, I believe, is 64. Now we can take the square root, and what you'll notice is if I take the square root of these, I end up taking the square root of a negative number, and that is a no-no. So this is no solution. Alright, number 18 gives us 4x squared minus 64 is equal to 0. So I'll add 64 to both sides. Those will cancel out. I'll be left with 4x squared is equal to positive 64. Now here's where a lot of people took the square root, but you cannot do that yet. Reverse PEMDAS, we have to divide by 4. These will cancel out. I'm left with x squared is equal to 16. Now I can take the square root of both sides. Those cancel. I'm left with x is equal to positive or negative 4. Again, cannot forget my positive or negative. Alright, 20 says we have to solve by completing the square. And the equation it gives us is x squared minus, oh, it's number 19, excuse me, minus 4x equals 32. So this already has c moved out of the way, which is perfect. Also, my a is already 1, which is perfect. So we can go ahead and complete the square. Completing the square says I'm going to go ahead and add b over 2 squared to both sides. Recall that b is the term connected to the single x, not the x squared. So I can go ahead and plug that in. I'll get x squared minus 4x plus, instead of b, I have negative 4, so negative 4 divided by 2 squared. And I have that equal to 32 plus b divided by 2, and b is negative 4, so negative 4 divided by 2 squared. X squared minus 4x, and I can simplify this next part. Negative 4 divided by 2 is negative 2. And again over here, negative 4 divided by 2 is negative 2. And I'm just going to keep going. Negative 2 squared is 4. Negative 2 squared is 4. So now that I've got this, I do have a perfect square. This can become x plus 2. Oops, that's not at all what I meant to say. Instead of becoming x plus 2, it will become x minus 2. X minus 2. 32 plus 34 is 36. This can be rewritten as x minus 2 squared is equal to 36. Now I can take the square root of both sides. Those cancel out. And I'm left with x minus 2. Now here's a mistake a lot of people made. They usually left the square root there. But the square root of 36 is plus or minus 6. Now here's where a lot of other people stopped doing things, but you have to keep going. I can add 2 to both sides. If I do that, those cancel. I'm left with x is equal to either plus or minus 6 plus 2, or you can write it the other way. X is equal to 2 plus or minus 6. Either way, you have to take these and separate them. So we'll just look at the first one here, because we're not done. This is going to become x is equal to positive 6 plus 2, and x is equal to negative 6 plus 2. So now I'm going to go ahead and solve those. Positive 6 plus 2 is 8. Negative 6 plus 2 is negative 4. Those are my two solutions. Alright, so I went over that one in pretty good detail, I think. So I'm going to run through the next couple of them. Again, if you're not understanding what I'm doing on a particular part of the video, please email me so I can get back to you. All right, number 20. So I just added 12 plus 9/4 there. This can be rewritten as x plus 3/2 squared is equal to negative 39/4. Now I'll root both sides, and you'll notice here this becomes x plus 3/2. But on this side, we're taking the square root of a negative number, which means that we cannot do that. So we can stop here and say that there is no solution. Alright, again, I'm going to go through the next one with not too much description. This is number 21. So actually here I do want to mention one thing. I have an a value, and I need to divide that out. So my new equation will be x squared minus x is equal to 8. I just got that by dividing out that 4. Now I can go ahead and complete the square. This can be rewritten as x plus, x minus 1/2 times x minus 1/2. 8 plus 1/4, well I can do that up here. 8 over 1 plus 1 over 4. In order to get a common denominator, I have to multiply both the top and the bottom of the 8 by 4. So I'll get 32 over 4 plus 1 over 4, and that will give me 33 over 4. This can be rewritten as x minus 1/2 squared. Now I can go ahead and root both sides. Those cancel. I'm left with x minus 1/2. This does not like it's going to root very well, so we'll leave the top alone. Since it's just 11 times 3, which is both prime. But we can take the square root of the bottom. The square root of the bottom will be 2. And remember, it's positive or negative. So now we'll just add 1/2, and we get x is equal to 1/2 plus or minus the square root of 33 divided by 2. Now, because the square root of 33 is an irrational number, we can't go any further than that. So this is your answer. Alright, number 22. Let me erase all this. Number 22 is asking you to use the quadratic formula. And again, you should know what that is. You should have it in your notes. But if you do forget, that's okay. You don't have to have it memorized. I will have it on the board. But number 22 says 3x squared plus 5x plus 1 is equal to 0. So we can set up our quadratic formula. Quadratic formula is negative b, and b is 5, so negative 5 plus or minus the square root of b squared, and again b is 5, so b squared minus 4 times a in this case is 3, times c, which in this case is 1, all divided by 2 times a, which again in this case is 3. Now we can start working with what's on the inside here. 5 squared is 25. 4 times 3 times 1 is 12, so you have negative 12. 2 times 3 on the bottom here is 6. 25 minus 12 is 13. And we can't go much further than this. 13 is a prime number, so we'll have to just leave it here. And this is our x. Notice there's two answers within this. It's negative 5 plus square root of 13 and negative 5 minus square root of 13. Okay. 23 and 24 are still both using the quadratic formula, so I'm going to skip the 24. This is just a matter of plugging things in. The 24 says 3x squared minus x is equal to 14. Now, one of the mistakes many people made is they started plugging numbers in, but this is not in the correct format. It has to be in standard form, so we have to subtract 14 on both sides. Those will cancel, and I'll get 3x squared minus x minus 14 is equal to 0. Now it is in standard form. Now I can plug it in to the quadratic formula. Negative b, well, b is negative 1, so negative 1, which is positive 1, plus or minus the square root of b squared. Well, b is 1, so 1 squared, minus 4 times a, which is 3, times c, which is negative 14, all divided by 2 times a. Now we can just keep going with our math. 1 squared is just 1. Negative 4 times 3 is negative 12. And negative 12 times negative 14. Well, 4 times 2 is 8. 4 times 1 is 4. 1 times 2 is 2. 1 times 1 is 1. 168. And a negative times a negative is a positive. 2 times 3 is 6. So we get x is equal to, x is equal to 1 plus the square root of 1 plus 168 is 169 divided by 6. Oh, this should be plus or minus, excuse me. The square root of 169 is 13. So we will get two different answers. Here's where a lot of people miss points. We have 1 plus 13 divided by 6, and we have 1 minus 13 divided by 6. And 1 minus 13 is negative 12 divided by 6. 12 divided by 6 is 2, and a negative divided by a positive is a negative, so there's one of our solutions. And I go back over here, 1 plus 13 is 14, so we get 14/6. I can divide a 2 out of both numbers. So I will get 7/3 as my other answer. Alright. (25) asks us to find the next term in our sequence. So if you've noticed, they're multiplying each of these by negative 1/6. So we can take the equation we were given today, a sub n is equal to negative 36 times negative 1/6 to the n minus 1. Now we can plug in the next term. We want to find the 5th, 6th, and 7th terms. So I would plug in a sub 5 is equal to negative 36 times negative 1/6 to the n minus 1, n is 5, so the 4th power. And if I do the math, I should get negative 1/36. And then we can use that to go to the next step. And you should get 1 over 216 positive. And your final answer will be negative 1 over 1,296. Alright, number 26. It says a computer is worth $4,000 when it is new. After each year it is worth half of what it was the previous year. What will this be worth after 4 years? So we're going to use our exponential decay formula. Oops, 1 second. I believe we are learning this the last day, so I've not actually taught you this yet, but that's alright. So the exponential decay formula that hopefully you have when you're watching this is y is equal to a 1 minus r t. So now we can plug in what we know. We know that our initial amount, the computer, was worth $4,000. That's the price of the computer. And we take 1 minus our rate, and they said that it was losing half of its value every year. So that's 0.5. And they want to know what its value will be after 4 years. So the time is 4. Now we just math things out. 1 minus 0.5 is 0.5. 0.5 is the same as 1/2, and 1/2 to the fourth is 1/2 times 1/2 times 1/2 times 1/2, which is equal to 1 over 2 times 2 is 4, times 2 more is 8, times 2 more is 16. When I multiply these, I get 4,000 over 16. And I just start taking out common factors. I know that I can take a 2 out of both of those, so that becomes 2,000 over 8. I know that I can take a 2 out again, and that becomes 1,000 over 4. I can take 2 out again, because that's going to become 500 over 2. And I'll take a 2 out again, which is going to leave me at 250. So the price of this computer, and this does sound crazy, but this is probably fairly accurate given how fast computers change. It's going to be $250. And so it's important. This one's in a word problem, so you want to make sure that you end up with, oh man, that was terrible. You want to make sure when you write your answer that you're writing something like this. Well, apparently I can't write anything. There we go. Alright. 27 gives you a picture and asks you to find the vertex. Recall that in a parabola, the vertex is either the highest or lowest point, wherever that peak is. In this case, it's right there. And if you look on the graph, the vertex can be found at the point 1, 3. So we know that our vertex is 1, 3. Then it asks us to find the minimum or the maximum. Well, we know just by looking at it that this has a maximum and not a minimum because it goes on forever. And the maximum, the highest y value, is 3. That's the end of your study guide. Again, if you have any questions, please let me know. You can email me. Come see me before or after. I guess it wouldn't be after, but before class. Study well and good luck on your final.